How do I pause it?
Just push it once. Good afternoon, ladies and gentlemen. It's good to see such a distinguished group here today, from the engineering branch. Very good attendance. Anyway, what I want to discuss here today to explain is the difference between the ignition oven and the reflux method. As you know, we're into an age now where we're very prone to our environment. We don't want to contaminate soils or whatnot, or water supplies. And whereas we're into quality assurance a lot now, we have to have quicker test results. So what I'm going to show here is a comparison between the ignition oven and the reflux method. And I want to make you aware that in our mobile laboratories, we are still using the reflux method. And like I say, it's an environmental issue along with a health issue now. So anyway, I got a few slides here I want to show. Now this is for you people that maybe not quite aware of the reflux method. This is a reflux, the jar, and we got a hot plate. And we're setting the baskets with the mix into the jar there now. And this chemical that's in it is a triethylene. And when they heat it up, it evaporates and goes up and hits the condenser with cold water running through it. And in turn, that brings it into droplets, and it drops down through the mix and extracts the binder out of it. So it's a health issue because of the fumes coming from it, and it's time consuming, and it's not as accurate as ignition of it. Now this is the ignition oven. It's a thermaline. This is no sales pitch, sales talk for the thermaline ignition oven. But in our stationary labs, Fredericton, Moncton, and Bathurst, we have used these, and we found them very reliable and very accurate test results. So, here on your right, we're preparing a mix for ignition. As you can see, it's being placed in the baskets. And now here, this is after ignition, and as you can see, this is the mix after ignition. There's next to no residue of any binder. You just got your aggregates. Now for the next slide I have here is a comparison of the timeline to determine 5% binder in the mix. Now our target is 5%, and how we know this was all calibrated. It's all pre-mixed up, we know exactly what it had. So anyway, with the ignition oven, we're looking at 45 minutes to determine a 5% AC content. With the reflux method, we're looking at 4 hours to get that same 5% binder content, which determines to something like 81% longer than the ignition oven. And then we have health issues, and we got an environmental issue. So it's not very good for our employees to work in a lab and have to contend with triethylene. Okay. Now for our next slide. For our next slide, we're looking at the accuracy rate. Now, like I was saying, it was 5% target we're after. We know that because we made the premix ourselves. We know it's exactly 5% when we made up the mix. Now, with the ignition oven, we can get 5% right on because we can calibrate it. If we have any dust loss, we can calibrate it over, say, 6 test samples with different binder contents to determine exactly what the correction factor is. Now for reflux, we can't do that. I mean, out on the field, it would be very, very hard to do. With the dust loss, with the correction we got there is 0.25%. And with that dust loss, the only way we can retrieve that is we got to pour off that triethylene into a centrifuge. And then it's got to be spun out so we can retrieve the dust. Then we got to turn around and put it in an oven and dry it. So we're looking probably another 2 to 3 hours on top of 4 hours to get an accurate binder content by using the reflux method. Which out in the field, I mean, with our quality assurance now, it just don't cut it. Because, you know, let's face it, we have anywhere from 3 to 6 samples a day that we've got to do. So it's just not the way to go. Just not the way to go. I mean, to recap on this, the ignition oven, we're looking at faster test results to find out binder content, also gradations. We can find out a lot faster than with reflux. We're not concerned with health issues, minimal health issues, you know, compared to the reflux, which, you know, we don't want any of that, you know, for compensation reasons, whatnot like that. It's just very fast for our test results. And one of the big things with reflux now is the disposal, you know, of triethylene. It's very costly now to get it disposed of. But as you can see, we got 6 mobile labs, and we would like to equip these labs with these ignition ovens, you know, to get away from the reflux method by using that chemical. Because no health, we don't want to have health issues, and we don't want to have environmental issues. So I'll leave that with you today. And like I say, if you have any questions,